Okay, today the curriculum will be about understanding covariance and partially square stress equation model. This is based on theoretical approach. So, and I show why this doubling something. Okay, so the first thing that we're going to discuss what is actually structural equation model. So for this structural equation model, uh, this is one of the highest level of analysis in our field, either in education or in education only. So this is one of the highest level of statistical analysis. So this the most complex and most powerful. And if you have this model inside your PhD study or perhaps in your paper, normally there will be no issue in terms of probability or in terms of level of or vastness of your statistical analysis. Okay, what is actually SAM? Okay, SAM is a statistical technique for examining relationship between latent variable and observed variable. So we have two variable, dependent and independent variable. So what we can do using SAM that we can understand the relationship between this variable. So it allows researcher to test hypothesis about causal relationship and estimate model parameter. So what is causal relationship? For example, you want to understand perhaps what are the factors that contribute toward someone to buy a product, for example. So this is quite a very popular example. So maybe we have price variable, so you're going to understand which variable they are going to impact the intention to buy a product, and you also can understand which factor is going to give the highest impact towards this kind of behavior. So it's not limited to behavior. So you have any suitable latent or observed variable, you can use it to understand it. So you can use this SAM. And SAM offers a powerful tool for understanding from the relationship between variables, including both direct and indirect impact. So if you go further for structural equation model, so you're going to have another, what I call it, another level where we call it as direct and indirect effect. So normally, when you have the composite effect analysis, you have the Bayesian model, you have the structural model, so you can study the direct and indirect effect. So if you're using direct and indirect effect, it will be more toward understanding the mediation effect of a variable. It's particularly useful for studying constructs that are not directly observed, such as motivation, learning, or engagement. So this is another school of thought. So they say that motivation, learning, and engagement, something that's not really explicit, can be understood using SAM. Okay, so this is basically how you're going to use SAM. And then you have to understand it. So most of the students, based on my experience, I am an editor for journal, so as well as for examiners and reviewer for paper. For I had reviewed around, I think, more than 100 high impact journal, high impact article. So normally there's this confusion between what is covariant based SAM and partially square SAM. Okay, so basically how are we going to understand what is covariant based SAM? So covariant based SAM is that when you are using IBM Amos, so if you're using IBM Amos, it will be covariant based SAM because Amos only at this moment only able to measure or to formulate model based on covariant based approach. However, if you're using other software, so one is at IBM Amos, another popular software is Smart PLS. So for Smart PLS, it can be using partially square, and I think around last year, maybe last year or last 2 years, uh, SmartPLS had released a new algorithm where you can also use covariant-based SAM inside the software. So this is you have to understand. So if you're using covariant-based SAM, so you're going to use AMOS as well as SmartPLS. If you're using partial least square, so you have to use SmartPLS and other suitable software. Okay, what is covariant? What is covariant-based SAM? So for covariant-based SAM, this is based on covariant matrices, as then it assumes normality, require large samples, and focus on complementary analysis. So if you're using covariant-based SAM, normally you need large sample. So then the stuff must be normally distributed. So this is not normally distributed by using what I call it, Shapiro-Wilk or Kolmogorov-Smirnov. So what we assume the normality assumptions that you have to make sure that your data is normally distributed from the perspective of multivariate. So this is multivariate normality test. So you have to test your kurtosis, you have to test your skewness to understand either the data are normally distributed from the perspective of multivariate or not. If you are using Shapiro-Wilk or Kolmogorov-Smirnov, this is focusing toward the univariate nature of the data. So please understand this, because if you are using covariant-based SAM, then your data are not normally distributed. So this is high likelihood that your finding might be wrong. So be careful with that. So this is some other major issue in Viper, as a major issue when researchers submit their article. Okay, for partial least square SAM, is used partial least square. This is less restrictive in terms of assumption. Normally, we don't really focusing toward the normality of the data once if you are using partial least square. And it's suitable for smaller sample. So I have seen, I think 50, someone are using 50 sample for partial least square for publication. Not in high impact journal. I think that's a normal journal. So for PhD study, I believe it is not possible to only have 50 sample for partial least square. So you need at least some bigger numbers. So how to determine your sample size? You can use Craigie and Morgan table. It's focused on predictive power and explanatory capacity. Okay, in other words, to conclude that, if you are testing a model, for testing a theory, you have an existing theory, then you're going to test this theory again. So maybe you make some improvement, you make some amendment, you improve the model, the theory better to become better. So you are testing this theory. So normally, I will suggest for you to use covariant-based SAM. However, if you are trying to make a new theory, or maybe have something that's really complex, to have a lot of variables, then you can use partial least square to test your data. Okay, so that's the same thing as I said before this. Okay, the model complexity. If you have a very complex model, you have so many variables, you have so many items, so you can use the SM. However, normally up to the latest standard or latest practice, from my experience, even we have a very complex model, so we still can use covariant-based SAM. So almost still able to analyze the data. So I don't find any issue if you're using AMOS, but I'm not sure if what is the term of complexity. Maybe you have, for example, 30 variables, then this might have been some problems. But so far for me, I use a lot of variables, so it still can the model that we designed using covariant-based SAM still able to converse, and we have no issue with producing the model. Okay, so this is basically what is called variable sum, what is partially square sum. Then what is the differences between the two? Then we're going to focus on how, for example, how you going to apply covariant descent in technology enhanced learning study. Okay, you can use to understand online learning, for example. Take covariant descent can be used to determine the impact of online learning intervention on student motivation, engagement, and academic performance. For example, you have a group of sample, then you make some intervention using online learning environment, for example. So you have the pre-test and the post-test. So maybe in the pre-test, you ask them to answer your questionnaire. You can understand what is the impact or the relationship between motivation, engagement, and academic performance. How academic performance been influenced by motivation and engagement. And after using the online system, for example, maybe for 6 months, then you can collect data again. You can use the same questionnaire. Then you can see if there's any impact on academic performance based from the perspective of motivation and engagement. Or perhaps you don't want to make any pre and post test. Maybe the students are very fluent, where students are very progress with using this online learning environment. For example, in university now, everyone use e-learning. Everyone using the IMS, everybody are using the CMS. So perhaps you want to understand what are the impact of motivation, engagement, to the academic performance of the student. So when they have the experience, you just come to them, ask them to answer the questionnaire. So this is a very simple example. So don't use this for PhD study. So because for PhD study, you need to have novelty, you need to have something new. So this is this example. Then for collaborative learning. So if you want a compare example, we're going to give you the compare examples later. Okay, for collaborative learning, okay, collaborative SAM can assess the effectiveness of collaborative learning environments in promoting knowledge sharing, problem solving, and group performance. So meaning that if they are learning using collaborative learning approach, or perhaps collaborative, what I call it, collaborative system or system that you design to promote collaborative learning. So you can understand the relationship between this variable using the covariant descent. Then another example is cognitive load. So this is the test example for your for your understanding is that normally we are no longer focusing a lot toward cognitive load. So even I met some scholars, they say that cognitive load is not something that's current. Even one of the scholars said that cognitive load theory is not correct. So that might be his or her opinion. So if you're using cognitive load. So covariant same can be used to study how technology enhanced learning environment affect cognitive load and learning outcome. So this is the example of how to use the covariant descent. Okay, so I'm giving you example, compare example, how covariant descent can be applied into our field in addiction technology or advanced learning technology. So I'm going to share a number of articles. Okay. Okay, so this is the first article. So this will publish all of this article will be published in High Impact Journal. So this is my article. So I don't really like prefer for my student to publish paper for me. So I prefer to publish my own paper. My student, what they have to do is just publish for the purpose of their graduation. So they need to have the Bible session, just publish for themselves. So they don't have to functionality. Okay, so I'm sure they can you hear my voice because I am the library, I am the PRJS, because I can have the static software. So it's a library. I cannot talk very loud, otherwise people might be angry. Okay, so this yes, this is what I call it, the Carol room. So this Carol room, this is some echo with Carol room. So I try to change the setting. So is it now better? Just the same. So it's Carol room. The room is giving some echo effect. Is it better now? Okay, so I try to change the setting. Okay. This is the setting. Let me try this. Okay, so this is example. This is Q1 Journal published in 2022. Okay, what I did in this study is that, so we collect data. So from the data we collected, we combine two theory. So we have theory A and we have theory B. So this theory, there's some business gap. So we combine it together. So we use covariant percent to understand the relationship between all of these variables, and we come up with a new model. So this is example how you can use it for complex issue. Then we have another thing. So I have to just view. Okay, so this is also my article. So what I did is that I use the theory to predict. So you can use this covariant percent as well as the partially percent to make some prediction about if we have the kind of new technology, how the user is going to react, how they're going to use, or perhaps you want to understand what are the motivation behind why they're using a certain system or certain technology. So this we have mediation analysis, so a structured equation model and mediation analysis. So I think in this paper I use two software. Sorry, I think I use at least three software, and I had use IBM SPSS, then I'm using IBM Amos, as well as Smart PLS. So I'm using three software to to test the model and to come up with a new model. Then the slide is not showing. Sorry, I think no, I'm not showing the slide. I'm showing the website, the Springer and Elsevier publication. Okay, yes, we are now at the scope. So this is another article. Okay, so why is that we use a theory to understand the acceptance of a certain thinking scale. So then we can have a model. So this model is usable in that after a very robust testing, so we can understand what are the factors that influence the user toward the acceptance of competition thinking scheme. Okay, then this is another Q1 paper. So the main author is Prof. Lokman Tahir, professor from our faculty. So this is my name. So we can understand that to nature teacher creativity, what are the effect of leadership roles and what are the constraints? So from the leadership roles, the constraints, how it's going to affect the teacher creativity. However, in this article, we don't use the weighted percent totally. We are using qualitative perspective. We have some interview. We have the data, so the quantitative data is supporting our qualitative. So the qualitative and quantitative are supporting each other. So we can have what I call it now better a much holistic or something a model that comes from various perspectives, not just from one perspective. So that's the purpose why we're using mixed method for this article. So I have other purpose, but this is one purpose that I can show you. So sorry, I cannot show you the whole article because you have to access Elsevier and Spring Nature to have the paper. Okay, so that's an example how you can use it. So as I said, this is one of the most complex and most this is in our field. So it's very impactful if you can able to understand or able to master this kind of analysis. So from my experience, I had practicing for actually 5 years, 5 years using all the software. Then after that, I tried. So maybe I practice first, and after that I apply. So I practiced for 5 years, and then after that I applied the skill. So it takes a lot of time to understand the analysis. It takes a lot of time to not only able how you're going to able sorry not only to make sure that you're able to understand, able to perform the analysis. It's also take time for you to able to understand what's the output of your analysis. And sharing back the okay, so that's I think example on how you can use covariant based set. Okay, so this covariant based set. So please understand when you come to your Viva session, covariant based set is not toward testing an existing theory. So if you want maybe perhaps come up with a new theory or maybe your model are too complex, so you can use partial least square structural equation model. So again, please understand, most of the students even use this in their Viva. What are the differences between covariant based SAM and partial least square SAM? So partial least square and covariant based are different approaches, different assumptions, and normally it's focusing for different goal in I call it conducting the study. Okay, for partial expression, it's more toward handling formative construct and higher order model. So what is higher order models? Mean that the model have so many variables. Okay, for formative construct are measured by their effect on other variables, whereas SAM allow researchers to estimate the quality of these uh, construct, while covariant based SAM does not able to understand, not understand, to measure the quality of this construct. So if you are going to focus on quality of this construct, you can use specialist square. Okay? And higher order model represent a complex construct with multiple dimensions. So what is multiple dimension? Again, you have so many variables. However, from my experience conducting research using structural equation model, I think I had collected around maybe 10,000 data. I cannot remember, I think 10,000 data. So meaning that the data involving different kind of pieces. So if you have too complex model, you have too many variables, it's going to impact your square, meaning that your variant experience, meaning that what the thing that can predict your depending variable might be impacted because you have too many independent variables. So I don't really suggest if you're going for a very complex model, unless if you have any special need for a very complex model. Okay, so in partial square SAM, we have the merging model, we have the structural model, So when you conduct this SAM, not only PLS, covariant-based SAM also have the same thing. So for the merger model, is that you're going to assess the reliability and validity factors. So here you have the complementary factor analysis, you have the construct reliability, you have the average value extract. So you have also another one is that most of the students will just stop at complementary factor analysis. So for if you start complementary factor analysis, CFP, so it's not good enough. So because they have a lot, now we have a lot of
Assalamu alaikum.
we have a lot of new work for it.
Assalamu alaikum.
We have a lot of new analysis such as HCM.
Assalamu alaikum.
So HCMT would be
Sir, the sound is not audible.
sorry.
The sound is not clear, sir.
So this is the best setting that we can use. We can change. Okay. So then for the structural model, you examine the relationship between the latent variable and testing the hypothesis. So this is for the structural model. Okay, this is PLSM application, methodology enhanced learning. For example, you want to study student engagement, adaptive learning system, virtual learning environment. So all of these, you can use partial describe. Maybe you're going to come up with a new model for virtual reality or new theory for virtual reality, you can use the partial describe. So the conclusion is that as offer valuable insight into complex research area in terms of the enhanced learning. However, if you are using covariant based SAM, it still have a very huge potential effect in understanding theory. We have a lot of theories in educational technology. So all the theories might need to be improved or might need to be amended. So you can still use covariant based SAM. So meaning that we cannot say that PLS SAM is better. Both PLS SAM and covariant based SAM has their own objective and their own direction and purpose for study. So for now, if you're using SmartPLS, this can be set as the emerging only for approach. Then we have another thing. So in PLSM, we have artificial intelligence and machine learning. So another analysis is coming where we call it as artificial neural network, ANN. So this artificial neural network can be complement using covariant based SAM or partially square scan to have the element of machine learning inside your study. So that's the new thing they're looking forward for new analysis. So you can focus on that. Okay. I think that's all for my talk. Any question about it? So any question? No question?